Today's lesson is a couple of questions on projectile motion. You remember roughs? Read the question, understand the question, filter the question, think about the formulas, and solve and check. So let's read the question. Miss Yen is standing on the flat ground and it kicks a ball with speed of v at an angle of theta, which is in between 0 to 90 degrees, pi on 2. The ball just passes over 2 meter high tree after 5 seconds. The tree is 30 meters away from Miss Yen. You may assume that G for gravity equals 10 meter per second squared, and X, the X component, is Vt cos theta. A Y component is a Vt sine theta minus half G gravity T squared. So here the V is initial velocity, the capital V. Now question A. Find the value of V and the angle of projection theta. So we read the questions and understand the question. So what are we looking for? Are the two things, value of V and angle of projection theta. What are the information? Before we start collecting it, I like to actually sketch the diagram from the question. Just rough one. Tree here, that's beginning when t equals 0. And from here to the tree is about 30 meters away. And that's from here at 30 meters and a 2 meter up when t equals 5. Here, x, and we don't know. Here, 30 meters, and it's 0 because it's a ground. In a vector form, the x and y components together, whereas this one, it tend to go separately. We start with initial, that would be like that, drives it, separately, but it's already given to us here, which is great, big bonus. So we don't have to actually drive all that. Just for your information, in general term, just main thing is the cosine theta, it doesn't change because it's dt. In terms of t, think of as cosine theta as just constant. And here you start from negative 10 or g, then we go down slowly. It would be v sine theta minus gt, and then the next one will be bt sine theta minus gt squared over 2. So that's basically what happens. So if you can just memorize it, it'll really help you. I mean, if you do lots of questions like this, you automatically will remember things. Now, that's all the information we collected. So now I'm going to pick the formula. It's finding a v and the theta, but I'm going to find the theta first and then I'll find the v. I've got 30 t equals 5, and then later on I'm going to use y equals 2, t equals 5, gravity is 10. So basically I'm using this point here. That's where the x component and y component is the same, and we can equating because that's where they meet. So that's what I'm going to use. So 30 and the 5 seconds, 30, x is 30, t equals 5. And of course, I'm going to use the formula here, the x component here. So it'll be 30 equals v times 5 seconds cos theta, which we don't know. And if I change that, 5 cos theta, v equals, now I'll just swap the place around, and that's my first one. Now, I didn't simplify 30 and 5. Later on, it'll cancel out because we know it's going to be 5 sine theta later on, and we have to put it together, and eventually we're going to make a 10 theta, and then 5 will cancel out. So I'm just going to leave it as it is. Next one, y is 2 there, t is 5, same, but here, because the vertical component here, I have gravity to think about. So those are 3 things. And of course I'm going to use the formula here right there. So it's going to be 2 equals V5, now sine theta, minus half gravity 10 times 5 squared. So make the V the subject, it'll be 127. V equals 127 over 5 sine theta. That would be my second one. So as you can see, 5 cos theta, 5 sine theta. If you were thinking that we're going to make it into tan theta, you're absolutely correct. First equation, equating it, and then with the second one. So I'm just going to write it 30 over 5 cos theta equals 127 5 sine theta. My aim is to make it tan theta, so I'm going to swap this 5 sine theta on the top, 5 cos theta on the bottom. So it's 127 over 30, and therefore it becomes tan theta is 127 30 theta equals inverse tan 27 30. Theta will be 76 degrees 43 minutes. It's not the end, is it? I need to find V, initial velocity there, when theta equals 76 degrees and 43 minutes. So I'm going to substitute theta into my first equation. V equals 30 over 5 cos theta, but we know what theta is now, 76 degrees 43 minutes. So put that in your calculator, you will get 26.11345 something dot dot dot. It'll be 26.11 into 2 decimal places, and it'll be meter per second. This will be 2 marks, because 1 for the finding of theta, 1 for the velocity. Part B. How far? It's a distance. How far? So your answer should be in meters. From the ground did Miss Yen hit the ball? So we are looking for this X here right now. Now from the diagram we know when it hit the ground, the Y, the vertical distance, will be 0, wouldn't it? So basically we're looking for X when Y is 0, when it hit the ground. We are going to use the formula X equals Vt cos theta. And from the part A, what do we have? All the information. Let's have a look. We know the initial velocity is 26.11 meter per second. And theta, we know that. The angle, 76 degrees and 43 minutes. Time, we don't know. So we can't just use X component formula right now because we don't have the T. So I have to go with Y formula first. T sine theta minus half gt squared. Now this question is given, or this X and Y formula. I think normally you probably have to drive it and then go into the next question. So we got all the information we need. Let's have a look. What do we have? The Y is 0 because it's on the hit the ground. V, we have the information there. Theta, yes, we do have that, 43. And then T, we don't know, but the gravity is 10, we do know. Put it all that in, be 0 equals 26.11 T sine 76 degrees 43 minutes. Take away, no space, so I'm just writing underneath 10 t squared. Quadratic equation I can see straight away. Lovely. And we got 0, so we can sort of factorize t, you know. You can sort of predict what's going to happen. So if we use your calculator, this is what you're going to have. Yes. And then we'll take the t out. You will have like that. You know, 2 t's we're going to get. T equals 25.41 and t equals 5.082. I'm just going to write this here. 25.41 minus 5t is either that or that. Okay, but we know that that's going to be the second one because that's the initial, so we don't need that. When the projection, the ball hit the ground, so here at the beginning t was 0. When it hit the ground, it's a 5.082 seconds. Okay, now we got the time, so that will be 1 mark most likely. And now we can use the formula, the x formula there. So x equals v is 26.11. Now we have a time t, 5.082, and then cos 76 degrees and 43 minutes. And that's it. Okay, so I'll put that in your calculator. 2 decimal places, 30.49 meters. Okay, so that's another mark there. So 2 marks. Now I'm going to moving on to the second question. A particle is projected from a point O on the edge of a cliff, which is 20 meters above water. The particle's initial speed is 40 meters per second at an angle of 30 degrees above the horizontal. So you may assume that, you know, G for gravity is 10 meters per second squared. All right, part A, drive x and y components of the displacement vector of this projectile. Let's have a look at understanding the question by drawing the diagram. Now, because it's in a vector, so we need to write it in a vector form here. So that's a resultant vector here. So you know that's just adding vector. So you know that's going to be V. I'm just going to write a vector like this. Okay. So what are they? Basically, that's V cos theta I vector plus V sine theta j. That's the vector form, right? Let me just put all the information here while we edit. So 40, we got the 40, and we got cos 30. Oh, so you got to do exact value here. Plus 40 sine 30 j. Okay, so that's not too bad. 40 times root 3 over 2, because cos 30 is root over 2. I plus 40 sine 30 is half j. So I simplify this. 20 root 3 I plus 20j. Let's put the vector here for this one. So that's the displacement at the beginning. It'll be 0 I plus 20j. So we'll just put it in a vector form. Okay, everything's good. So now on this one I can put 20 root 3 I plus 20j. The understanding the question part, there's a displacement vector. So we're basically looking at S. We got to go from acceleration down to vector on the velocity and then displacement. So we have to keep drive it. Okay, start from a vertical. Start from G acceleration 10j. V will be integral of acceleration dt. So therefore, if I put that in, it'll be minus 10j. Don't forget the j, because now we're on a vector form here. Minus 10tj plus c. Okay, so that's my first one. And then second one is when t equals 0, the v is all here, or this one, we already got that one, is 20 root 3 I plus 20j. And that's my second. When t equals 0, initially, they're both the same, isn't it? So I'm going to do that. I will get minus 10, t is 0, j plus c, or c vector. And then I'll go 20 root 3 I plus 20j, vector j. So therefore, basically, my vector c is 20 root 3 I plus 20j. Okay, so that's it. Therefore, v is now minus 10tj plus 20 root 3 I vector I 20j. Now you can see that same, and so I'm going to put it together. Therefore, 20 root 3i plus minus 10t plus 20j. What about 20 minus 10t? That's not bad, but I think I just want to put in order. Write it in order. So I'll put the t, whatever t in it, because you know it's eventually it's going to be like quadratic. So it's going to be t squared and t, and you know, t to the power of 0 sort of thing becomes constant. For that reason, I like to keep it as a t comes first. I'm going to keep going. Now displacement, we have to integral of that. You'll get 20 root 3 t, okay, don't forget the t, plus inside here minus 10 t squared over 2 plus 20t j plus constant vector d this time, because I don't want to use this, keep using same c because they're not the same constant, so I'm going to use d this time. I have to think about when t equals 0, the displacement in vector form was a 0i plus 20 vector j, so which means just 20j. So I'm going to make this 3 and 4 equate equals 4. So if I put that in, it'll be 20j equals, actually it's 0i here, because everything with a t, it's going to be 0 because it's t equals 0. Yep. So plus 0j plus the I. So therefore the vector is 20j. So I'm going to put that back in here. Okay. So therefore my S displacement vector is 20 root 3 ti plus minus 5t squared plus 20t, and I'm going to put this into here straight away because they are all in j terms, isn't it? So I'm just going to put that in. That is my displacement vector. This one is the x component, and this part is the y component. Okay. Part B, find the maximum height reached by the particle. Okay, maximum height. You'll probably start to think, which is the vector y equals 0 from part A. So I'm not going to use displacement vector because this is just the vector one. So I'm just using the vector information there. So this is the x component, that's y component. What we have is y, okay? So that's the y dot here and x dot here, okay? So I'm just going to use this one, minus 10t plus 20 equals 0 because of it's here, it says it's 0. So 10t equals 20, t equals 2. Okay, 2 seconds. So when t is 2, the particle reaches its highest point. Now we can use the displacement vector, 20 root 3 ti, just the formula that we got from part A, minus 5t squared plus 20t plus 20j. Again, that's x, that was y. So that's, don't forget, that's the velocity there. Okay, so now all I need is this one because it's a maximum height. So it's going to be y components vertical. Y equals, I'm just going to use this one, minus 5t squared plus 20t plus 20 at t equals 2. So I just substitute in to find the height, maximum height. 2 squared plus 22 plus 20. So put that in your calculator. 40 plus 20. Oh, well, easy. 40 meters. Best way to get used to this, I think that the more questions you do, the better you will be. Okay? So that's all for today's lesson. See ya.